going back to freshman year when I was still in biomedical and I was switching to my degree to mechanical engineering, SpaceX was just starting to get national attention for trying to land rockets vertically to make them reusable. They were not a really well-known company yet. They were just starting to get national attention. This was 2013. And one of the people from that rocket team at Vanderbilt had gone off to work for SpaceX. And I had just heard about the culture at SpaceX, how innovative it was, how much amazing work they were doing, the crazy things they were trying. And it just seemed like a really brilliant place to try and do engineering work. And so I thought, well, if I put all my eggs in this Rocketry basket of this Vanderbilt rocket team, maybe I'll get a chance at an internship and maybe a chance at a full-time job there, or at least somewhere similar. And so I really went all in on that and switched my degree to mechanical engineering, decided not to study abroad so that I could get as much experience with the rocket team as possible. My junior year of college, right in May, like at the very last minute, I had applied like in October the year previously to try and get an internship with SpaceX. And right at the last minute, they called me from headquarters and said, we'd like to interview you for this position, this internship. And within a week, I had somehow gotten it. I really didn't think I had done a super amazing job in the interview. A miracle happened and I ended up at SpaceX, and I was just super happy for that internship. And I flew right from school out to SpaceX in Los Angeles and Hawthorne. Right up until school started back up, I was still at SpaceX. And normally an internship is just 12 weeks, but the second school was over until the second started, I was there because I couldn't imagine a more exciting thing to do with my summer than be there full time. One thing that was confusing is I had no idea what it was I was going to be doing at SpaceX. The title of my internship said Loads Engineering Dynamics, and I did not have the first clue what that meant. My interviewer had asked me one question about something called the Nyquist criterion, which is the frequency that you need to sample a wave at, like a sine wave, to make sure that you get all of the peaks and valleys. And there's a rule of thumb for that it needs to be at least twice the frequency, usually 2.5 to 3 times the frequency. But I didn't know the rule of thumb, so I just kind of reasoned through it in my head. I had not memorized it. And so I was just like, well, if you sampled it at the same as the frequency, you would just get a peak every time and it would look like a straight line, and slowly work my way to something that resembled the right answer. And my interviewer really liked that. So I knew it had to do something with sampling. With data and things to sine waves. But I tried to Google it and there were a bunch of different things online. When I got there, I asked my roommate and he said, I don't really know, but I think they make the Mac. And the Mac was something I would come to learn a lot about in my time there. They did make the Mac, and that was actually one of the smallest things they did. But in terms of the team my roommate was on, which was a structures engineer, an RE, as we would call them, a responsible engineer, they were really heavy users of the Mac. So the Mac was quite important to SpaceX on the whole, but not necessarily to my team. So everything I learned while I was there, I learned on the fly. Dynamics engineering is actually a pretty well-established field, or loads engineering. Most of the time the job would be called loads and dynamics, but the order of the words, I guess SpaceX didn't put much care into that. In my internship, they had me doing a really novel project where I was trying to build a little portable data recorder for transportation. It was a great little sort of tinkering project for anybody with a makerspace, the design specs for that. And it was actually not really standard for what the people on that team normally do. It was just a great project for an intern to have. But I did a good job with that, and they brought me along to other bigger things, and I got more responsibility. And by the end of it, I was lucky enough to receive an offer to return there full time once I finished my degree. They still required me to get a college degree. So I went back for my senior year with a job in hand, which was just the best feeling in the world. SpaceX, after graduating, we put all of our energy senior year into that rocket project. We were lucky enough to win NASA's student launch that year. It was just a great experience all the way through. I loved the things we got to do.
In the end, this load dynamics engineer, what was your job?
So it was a variety of different things. There were probably 12 or 15 people in loads and maybe 30 people total in dynamics, which was a larger umbrella over loads. And we were responsible for everything that went on the rocket, not falling apart from vibration or shock, or basically any type of forces that would cause the rocket to disassemble that vary with time. And pretty much all forces vary with time. Liftoff, big aerodynamic forces, these things cause a lot of vibrations and oscillations and shocks on the rocket. And the way the rocket and the different parts of the rocket respond to those vibrations is very technical and not really well understood either. And so anybody designing something new for the rocket, anytime we were flying a rocket through a new trajectory or a new flight environment, or we made any changes to things that the forces imparted on the rocket might be different, that came across our team's desk, and we had to reckon with, will the rocket survive? Will someone's new satellite that we're flying survive? Is the satellite that we're designing strong enough, or that we're flying for a customer, is that going to be strong enough to withstand the forces of flight? It was a huge variety of things, a lot of testing, a lot of analysis, a lot of data collection. There were times I got to do research. Well, one of my favorite parts is that I got to work with a huge variety of different teams working on different elements of rockets, spacecrafts. I started with Falcon 9, then I did a lot of work on Dragon, then I did a lot of work on the Starlink satellites, and I just touched my feet into Starship. When I was leaving in 2020, I joined in 2016. Most of our forward-thinking research was either going hard into Starlink or into Starship. And so I took on a lot of responsibility on Starlink, but at the expense that I didn't get to work a ton on Starship. So some of the tools that I had built were still being used on Starship, but most of my daily attention was more on Starlink things. And I really liked that. SpaceX had incredible office of really awesome and kind and bright people working on the Starlink project up in Redmond, Washington, near Seattle. And so I got to travel up there, and I just adored my time getting to be up there and working with that team, and some of the advanced technologies that they were developing for Starlink, particularly space lasers, or laser comm was a novel technology that we definitely had not figured out yet while I was there. And so we were hurling a ton of energy and attention at trying to figure that out.